So tonight's presentation is on types of rock. There are going to be slides where there are words underlined. I'd like you to write those down in notes. There's no quiz to take tonight. There's a couple of places where I say write this down also, or I ask a question, do you know what this is? Do you remember this? And write down that as well. So I want you to write all those things down, more if you want, but all those things down in your notes tonight. Well, what are rocks? Let's start by remembering what minerals are, because we learned about minerals first, and we learned that minerals make up rocks. So minerals are solids, naturally occurring solids that are formed from inorganic things. They have a set chemical formula and a crystalline structure. So rocks are also naturally occurring, okay? They're naturally occurring solids, but they're mixtures of one or more minerals and or organic matter. So there can be organic matter in rocks. Sometimes there is, sometimes there isn't. And minerals are possible as well. Rocks are classified by how they're formed, their composition and their texture. And rocks change over time through something called the rock cycle. So you guys have learned about the water cycle in the past. Rocks are cycling around all the time as well. So classifying rocks. Rocks are classified into 3 different groups. So the first group is igneous rocks. And that picture at the top left there of the dark gray rock with like holes in it, that's igneous rock. Sedimentary rock, that was the one that says sediments and sedimentary rock. Sedimentary rocks often have layers that you can see in them. And finally, metamorphic rocks we don't call them layers, we call them foliations in metamorphic rocks, but sometimes they do have bands that make them look kind of like sedimentary rocks. So igneous rocks are the first type of rock we're going to learn about. Igneous rocks begin as magma. So magma is like molten or liquid rock deep inside the earth, okay? Magma is a mixture of the things that make up rocks. Lots of different minerals. Magma forms when rock is heated, when pressure is released, because high pressure is going to give us more of a chance of a solid, low pressure is going to give us more of a chance of a liquid, and when a rock changes composition. So what's happening here in this picture is there's this pocket of magma deep here inside of the earth, okay? And when there's a little opening or a fissure in the earth, the magma can come out, and here it's giving us, hopefully the animation will come back to match up my lines here, giving us, here's a volcano. The magma, when it comes out, when it hits the Earth's surface, it's called lava now instead of magma. Same thing, just whether it's inside or outside of the Earth's surface, okay? And here it becomes igneous rock. We call it extrusive igneous rock if it cools on the Earth's surface. If you notice, when the magma starts coming up, there are some places where the magma kind of branches off still inside the Earth, over here. These are called magma pools, okay? And rock can cool here too. And we call that intrusive igneous rock when it cools inside the Earth's surface. Extrusive when it cools outside of the Earth's surface on the crust. Okay, so 2 different types of igneous rocks. And on the next slide, the next couple of slides, you'll see the differences in what igneous rocks look like. I'll have some samples for you to see in class tomorrow, but know that some of the igneous rocks, the ones that cool here inside the Earth, cool more slowly. They're going to look a little different, even if they're made of the same exact materials, than the ones that cool here on the outside of the Earth's surface, because these are going to cool more quickly. So here are pictures of 4 igneous rocks. Some igneous rocks you can see the speckles in them or the different minerals in them. Some of them you can't. The color looks a little bit more uniform. And we call the ones where you can see the speckles or the different parts coarse-grained, because those rocks formed more slowly, cooled more slowly over time. And so there was time for those grains or those crystals in the rocks to grow and get bigger. The ones that cooled more quickly are fine-grained, and usually they have a more uniform color and appearance to them. If you look closely, especially with a hand lens, you can see teeny tiny little crystals in there, not nearly as big as the ones that you can see in the coarse grain rocks. Write down coarse grain and fine grain in your notes and write down the names of these rocks, and maybe even like a picture, draw a picture of each of them as well. Obsidian is another igneous rock. I'll have some samples of this tomorrow in class. It's a dark colored volcanic glass that forms from really, really fast cooling of molten rock. It cools so rapidly that no crystals at all formed. So in the basalt, if you look at basalt up close, and I'll show you some basalt in class tomorrow too, you can see little tiny grains, not like granite at all. But igneous rock, you don't see any grains at all. It really looks like glass because it cools so quickly. The next type of rock is sedimentary rock. And if you look at this animation here, you can see that it's raining. And when it rains, the surface of the earth is kind of changing. It goes from the river kind of gets bigger, and the lake that's there gets a little bit wider. And so what's happening is this sedimentary rock, the sediment is being deposited at the bottom of this lake, and then over time it turns into sedimentary rock. So sediment is small pieces of solid material that come from rocks or living organisms. It's when things break down. They get moved from one place to another. Does anybody remember? Think about this. If you remember this from 6th grade, what the term is when sediment gets moved. If you remember that, write it down in your notes. Sediments are deposited in layers with the older ones at the bottom. So if I look at this group of sediments here, this is going to be the oldest, way down here. And the newest is going to be this purple layer that's going to come right now that I drew up here. Okay, so oldest, a little less old, a little less old. These are all deposited on top of each other, one on top of each other. And eventually, over time, the layers of sediment get compacted and cemented together because there's a lot of pressure pushing down on all this old sediment down here from all the new layers that are put on top. Imagine if, like, you guys all pile on top of each other. The person at the bottom of the big pile of people is going to feel the pressure of all the people on top of them. That's what's happening with sedimentary rock. And that's how it gets compacted and cemented together over time to make a rock instead of just a layer of sediment. Sedimentary rocks are formed at or near the Earth's surface. So igneous rocks we saw were coming from magma well inside the Earth's surface. Some of those magma pockets were actually forming igneous rock in there too, inside the Earth's surface. Here, sedimentary rock is only happening at the surface or a couple layers below the surface. There's no heat, there's no pressure like there are with other kinds of rocks. There's a little bit of pressure from the other layers being on top, but not intense pressure like we have on the inside of the Earth. And this is really the only type of rock that you're going to find fossils in because you don't have a lot of heat and pressure, which would change the type of rock around. And if you remember that animation with the water and the sediment depositing at the bottom of the lake, obviously if things are dying, creatures are dying, they're ending up in that lake and they're ending up in that layer of sediment at the bottom of the lake to make a fossil. So last type of rock is metamorphic rock. Metamorphic rock is rock that's been changed by temperature, pressure, or reactions with hot water. Many metamorphic rocks form under high temperature and pressure deep underground. So that's like the igneous rock that's forming underground, the intrusive igneous rock. That's how metamorphic rock, similar to how metamorphic rock is forming as well.